Good morning, good evening, good afternoon, good whatever time of day it is and whatever part of the world you're at right now. Welcome back, and today we're going to continue our lesson on quadrilaterals. We've already talked about these four here: parallelograms, rectangles, rhombus, and squares. Now, the one that we have not discussed yet that we will be discussing for this video are trapezoids, okay? And trapezoids, we have two different distinct trapezoids. We have like what we call like our regular trapezoids, and then we have more specific trapezoids, which are isosceles trapezoids. But first, let's just talk about trapezoids in general, okay? Trapezoids have only one set of parallel lines, okay? So those sets of parallel lines are here. And the parallel sides are called bases. So for example, this would be base 1, this would be base 2. Now, the other thing are that we're breaking it down to characteristics so we know what to call the sides of the trapezoid. The non-parallel sides are called legs. So these two things over here, which are not congruent, so we're going to give them two distinct marks. This is a leg and this is a leg. Okay. Now, let's go ahead and discuss the properties of isosceles trapezoids. The legs are congruent. So the two things that I just identified as legs in this diagram, they're both congruent. All right. The diagonals of the isosceles trapezoid are also congruent. So in this one, oops, I was supposed to make those red. So let's do this real quick. Red. Now I can erase that and I can go with blue. So the diagonals are congruent. Those are not really good dotted lines, but you get the idea. The base angles are congruent as well. Now, base angles, okay, the base angles are right here. These angles here are congruent. All right. And opposite angles are supplementary. Now, these angles up here, and the other base angles, excuse me, because we have two bases. So we have to remember. So we have two sets of base angles. The top base angles are congruent, and the two bottom base angles are congruent. And opposite would just mean that those two, this angle here that I'm drawing from one corner to the other to the opposite corner, those angles, when you add them together, would equal 180 degrees. Okay? So those are just some good things to know about the isosceles trapezoid and trapezoids in general. Okay, so let's go down here and go ahead and take a look at some of these problems to see what we come up with. And we have a little note here. It says the mid segment of a trapezoid joins the midpoints of the legs and is parallel to the bases. Its length is equal to the average of the lengths of the bases. Now, all this sweet talk here basically means that average, it says, is equal to the average, the length of the mid segment. So mid seg is equal, okay, to 1/2 times base 1 plus base 2, right? Another way of looking at that, some people may write it as base 1 plus base 2 divided by 2, okay? But that's what all that nice talk there means, okay? Now, let's go ahead and take a look at number 17. And this is our isosceles trapezoid. So we already know some things here. For example, we know that CE is congruent to FD. They're equal, okay? And if we forgot, we can go right here. It says the diagonals are congruent. So that means that they're the same length. So when we go ahead and look at this problem here, oops, I didn't mean to erase it, but let's go ahead and redraw it. CE, that's one of the diagonals. FD is another diagonal. They're congruent. So 9x minus 22 equals 4x plus 3. Subtract 4x from both sides, you get 5x minus 22 equals 3. We add 22 to both sides, you get 5x equals 25. And then divide both sides by 5, x is equal to 5. They want us to find CE. So we just have to plug x into CE. CE is equal to 9 times 5 minus 22. That's going to give us 45 minus 22, which is equal to 23. So our final answer, CE and FD are both equal to 23. All right, let's take a look at number 18. Number 18 reads, the measure of angle FCD. So let's highlight that, FCD. FCD. So we know that this angle is congruent to this angle here. Let's just keep that in mind. Then they tell us about angle EDC. So ED, and then C, we'll keep it on top. Okay, those two angles are congruent. So that's how we're going to set up our equation first. Our equation is going to read 8x minus 1 equals 3x plus 39. Okay, when we go ahead and solve it, we subtract 3x from both sides. That's going to give us 5x minus 1 equals 39. Add 1 to both sides. That's going to give us 5x equals 40. Divide both sides by 5. X is equal to 8. Now, what are they asking for? What do they want us to solve for? DEF. Now, let me go over here and highlight DEF. DEF is right here. Now, that's different from these two angles here, okay? So we know that remember that the base angles of an isosceles triangle are congruent. So the top base angles are congruent and the two bottom base angles are congruent. However, the relationship between those two angles is supplementary, okay? We should be able to add those two and they'll be equal to 180. So with that being said, we need to figure out what angle EDC is, and then we should be able to figure out what angle DEF is. So we're going to plug 8 back into DEF. Excuse me, not DEF, but EDC. So EDC is 3 times 8 plus 39 All right. 3 times 8. That's going to give us 24 plus 39. And 24 plus 39 is going to make, what is that, 63? So now that we know that EDC is 63 degrees, then that means that this angle is also 63 degrees. And now if we want to find the base angles at the bottom, we just need to subtract 63 from 180. So DEF is equal to 180 minus 63. And 180 minus 63 is 117. And that would be our final answer. 117 degrees. Okay? All right, we got one more question here that we're going to take a look at, number 19. And then we'll wrap up this video lesson on trapezoids. Number 19, they're asking us to find VW. Let's underline that a little better. VW. So VW. Now, VW is the mid segment. So this stuff up here in that box that I had boxed off some stuff in red, that's what we're going to be using now. So, and we already said that up here, that last sentence reads, its length, and it was referring to the mid segment. So the mid segment's length is equal to the average of the lengths of the bases. All that to say that if you add the other two bases together and divide by 2, that's equal to the mid segment. So let's write this out using the segments here. The mid segment is equal to the sum of the two bases, so ST plus RU divided by 2. And now we're just going to replace those segments with the expressions. So VW is, what is that? 3x minus 21 is equal to ST is going to be x minus 3, and RU is plus, that's going to be plus 41, and all of that's going to be divided by 2. Now, that's how you set up the equation. Personally, with this type of equation, I would suggest clearing the fraction, which means that we're going to have to, for this one, we're going to end up multiplying both sides by 2. So on this side, everything has to get multiplied by 2. All right. And over here on the right side, the 2's are essentially going to cancel out. So this is what it's going to look like real quick. 2 times 3x minus 21 is equal to x minus 3 plus 41. And now we can go ahead and simplify everything. Okay. So that's going to become 6x minus 42 equals x plus 38. We're going to subtract 1x from both sides because this is really 1x right here, right? This is really 1x. So when we subtract 1x from both sides, we get 5x minus 42 equals 38. And I'm going to just keep this going right here. If we add 42 to both sides, we're going to end up with 5x is equal to 80. And now we're going to divide both sides by 5. X is equal to 16. Like I said from the beginning, though, like they instructed us to do, they want us to find VW. W. So VW is equal to 3x minus 21. So that's going to be 3 times 16. Oops, let me make that look a little better. There we go. 3 times 16 minus 21. 3 times 16 is 48. And 48 minus 21 is 27. And so that means that 27 VW is equal to 27. And if we wanted to know what ST is, we would just plug in 16 and be 16 minus 3, which this would be 13. All right, so there it is. You all have a great day. That will conclude this video, and I'll see you all back for another lesson in the future. Deuces.